Okay, a selection of questions that you might attempt before looking at the solution. So we have a uniform sphere is moving with a speed of 30 meters per second on a smooth horizontal surface when it collides with a smooth vertical wall. After the impact, the sphere makes an angle of theta with the wall where tan theta is equal to 3/4. What I want to do there first is I'm given tan theta is equal to 3/4, so work out what sine theta and cos theta are equal to as well. Alright, given the coefficient of restitution between the sphere and the wall is 1/2, determine the speed of the sphere after the collision. So what do we need to do? We need to write the initial velocity vector in I and j form, identify which one changes, which one stays the same, apply the coefficient of restitution on the one that changes, and then the other one stays the same. So initial velocity vector and final velocity vector are there. PHI is phi, and that's the circle with the line vertically through it on the left-hand side. So then there's no momentum exchange parallel to the wall, so there's no impulse exchange parallel to the wall, so the i's will stay the same. The j's do change, so that's where the E is equal to minus V over U comes from. And then if we divide one of those by the other, sine over cos will be tan, and then we can solve. Or if you want to get the velocity straight away, you can use that method. For me, I think it's easier to get tan of phi equals sine phi over cos phi, so that's 3v over 75 divided by 2v over 75. Get the angle from that and put the phi then back into the initial velocity vector, getting the speed from that vector. Okay, question 2. Try the question and then have a look at the solution, but it's the same thing. Your initial and final velocities in IJ form, which one changes, which one stays the same. If it stays the same, leave the before and after components equal. If it changes, use E is minus V over U, and then put the two equations to get your answer. Question 3 then, and the final one here in this video, is the same, so I'd ask you to do this question and check your solution there as well.